Alright, in this screencast what we're going to look at is how to name ionic compounds. Here we've got 6 examples. We're going to need a periodic table and and just follow along these steps. So for this first one here, we have Na and F, and the key there is to figure out what is this. So we find on the periodic table, we find that Na is sodium, so the first name of any of these ionic compounds will just be the first thing written. And then the second part of this is just going to be the second element with an IDE ending if it's just one element. Here this is fluorine. This would become fluoride. So this would just be sodium fluoride. Easy piece of cake. Here we're going to kick it up a notch a little bit. Same rules for the first name. We're just going to find the whatever K is on the periodic table. K turns out to be potassium. And CO3, here we've got 2 elements acting as one unit. We call that a polyatomic ion. So we're going to look to that sheet that I've given you that has all the different polyatomic ions listed. We're going to find that CO3 is called carbonate. So this is just going to be carbonate. We don't have to worry about charges with these. We will eventually have to deal with charges, and we're going to get there when we get down to this one here. Again, similar instance here. We got magnesium, and we've got chlorine. And this is just going to become magnesium chloride. Down here, very similar to the second one here, we've got Be, and Be is just beryllium. And OH is a common ion. It's one of those polyatomics, just like CO3 was. So the first name is just what's written on the periodic table. And then the last name is the name of this polyatomic. So this would just be hydroxide. The way we realize this is if you count the number of different elements. In this one up here, we just had 2 elements. Here we had 3 elements. Here we just had 2. Now we're back to 3. Anytime you've got more than 2, you're going to have to look for usually the negative part, the second part written on your sheet of common ions. Let me take a look at this next one down here. Sr is strontium. Whoops. And S is sulfur, so this is just going to become sulfide. And then the one that's going to be a little bit trickier down here is this copper. Copper is a transition metal. As such, it can have many different charges. So we need to figure out what the charge is on this copper, because if we just left it as copper with the last name, it turns out it's going to be sulfide. We could mean any number of different compounds, each having their own properties. So we could run into some trouble if we get the wrong type of copper sulfide. So the way we differentiate the different coppers is by determining what the charge is on the copper. And there's a little trick to do that. We know overall this has to be neutral, so the amount of negative charge has to be canceled out by the amount of positive charge. So what we need to do is find the charge on the negative ions. And sulfur is in group 16. It has 6 valence electrons. It wants to have 8, so to go from 6 electrons to 8 electrons, we need to gain 2 electrons. That's going to give us a charge of -2. But if you look, there's only 1 sulfur. So that 1 sulfur has a total charge of -2. If there were 2 sulfurs, then we would just double this charge. If there are 3 sulfurs, we'd triple that charge. But we know overall this compound is neutral, so we have to balance that -2 out with a +2 charge over here for the copper. How we find the charge on just 1 copper is we look at how many coppers there are. In this case, there are 2. And we're going to divide our total charge by the amount of coppers that we have. So 2 divided by 2 just means that this 1 copper has to have a charge of 1. So we would write this as copper Roman numeral 1, which is going to tell us the charge of it, sulfide. If you look to the next video, we'll go in a little bit more depth, more practice with figuring out the charges of our transition metals in these.